Hello and welcome to Krakow Tech Talks. Today, Tech Talk will cover the DNS protocol. Presenting will be Michał Kuca. Michał joined our Krakow office 3 years ago, and he's over here to take it from me. So please welcome Michał and take it away.
Thank you, Paweł, for that introduction. Before we jump into details, I really want to ask you one question. Do you know what's this IP address? Anyone? One of Krakow universities. Next question, a little bit more difficult. What's that one used for? Any ideas? Embassy of India, located in Warsaw, in Poland. Now the question to you, how many of those you can remember by heart? It's really difficult, right? Why? Because we are not computers. We don't have any built-in memory that allows us to memorize a lot of them. That's why we need something more, something smart, something that will do the job for us. Here it comes, domain name system. All we have to do is just memorize an identity, a domain name, a string, something that is mapped, attached to the web page, to the person, to the identity that we would like to open the page for. Now, what we typically do, we are typing in our browser the domain name that we remember, and our computer will do the job for us. So it will send the request over the internet to the DNS server, which is responsible for getting the IP address for that domain name. Why the IP? Because computers talk to each other using IP address, not a string. String is for us, IP is for the computer. You can make a comparison here between a phone book. Now you have smartphones, but you can imagine 20 years ago we had something like that. So when you really wanted to find a phone for Jan Kowalski, living somewhere, what you used to do, you were opening a phone book, going to K, Kowalski, okay, there's plenty of them. But then you are looking for Jan, still few of them. But it's just one Jan Kowalski who lives at Bajeczna Street in Krakow, right? And here is his phone number. That's more or less how DNS works. The agenda for today's talk, as you see here, is just a few points. I would like to focus on DNS Basics because that's the most important part, the crucial one. I really want everyone to understand how it works before we can jump into details. We'll spend some time on name resolution process so that you are really aware of what is exactly happening when you are typing something in your browser, what components are involved. Then I'll roughly describe domain registration process in case you really want to register your own domain and you don't know what to do next. You may expect some questions from me to you, so be careful. Listen to what I'm saying. I'll be asking something and you can win probably some nice award for that, for a good answer. So let's get started. To cover DNS basics, I divided this into a few parts. So first I will walk you through the history, then we'll go through features. I'll show you what's the domain hierarchy in terms of name servers and domain name itself. Then I'll describe a zone file, and finally we'll talk a little bit about different server types. It all started in the United States. First network that was deployed in 1969 was called Arpanet. It used to be Arpanet, now it's called Internet. It used to have just 4 machines, now it has really lot more. That time, there was no DNS. There was no complicated process system involved providing us that great technology. There was just one simple stupid host file. What it was doing, it was just having a mapping between computer name and the IP address. So you can imagine that it's really straightforward, very simple. When you have small network like here, having only 4 computers, even 10, is pretty straightforward. But what is happening when you have 10,000 machines? Suddenly, the file started growing, and it became really difficult to maintain. It was completely not scalable. You could imagine that when you wanted to do some modification over there, because the IP address was changed, you had to send an email to the guy who was responsible for doing that manual job. And now it was really up to him to do the work properly and do the modification you really wanted to be done. Finally, it was single point of failure. There was just one machine, originally just one machine, giving you the file back. As a result, when that machine went down, there was no domain resolution process. We had to do something with that. That guy, whose name is Paul Macapetris, coming from University of California, invented DNS system in November '83. It is described originally in 2 documents called RFC 882 and RFC 883. In its original version, it is there. So you can refer, you can find the documents, you can see how it was looking at that time. So let's try to talk about features he described in that document a little bit more. What is domain name system? Domain name system is hierarchical. What does it mean? It means that each domain name has a hierarchy that we can organize somehow in that kind of tree. So it has a root somewhere, it has some leaves, it has branches, and each single domain name can be situated somewhere on the tree. It is hierarchical also in terms of the physical machines, in terms of physical name servers. So you can have some servers that are more important than others. We'll talk about that later on. It is also distributed. It means that there is no single point of failure anymore. We have replication here. The machines are located all over the world. Now you may ask how many of them, where are they located? And I'll answer that. And finally, it's a database. Database, it means that it is not storing only an IP address for the domain name, but also we have other entries that can be saved together with our domain name. Domain name system, it's hierarchical distributed database. 3 simple words, easy to remember. Now, what is a domain name finally? Let's try to describe it a little bit. First of all, it's a string. It's a string that identifies something. It's a string that has some meaning for someone. Finally, that string has to be registered in domain name system. So that's a special string that was put somewhere in DNS and has some meaning. And finally, it is formed according to a syntax that is defined in our DNS, in RFC for DNS. You probably know that. Having that example, let me explain what each part does in that domain name. Starting from the very end, you have top-level domain, which is .com here. Then you have second-level domain, in that case, akamai.com. And finally, you have hostname part. Hostname part it's just www, or you can call a hostname www.akamai.com as well. One important point here, each domain name with a trailing dot over there is called fully qualified domain name. It means that it is complete domain name, starting from dot, top-level domain, and so on, to the hostname part. Top-level domains. They are maintained by IANA. We have few types of those, like generic domain names. You probably know them. That's .com, .net, .org, and so on. Country code domain names. So each country has its own top-level domain here. We have sponsored domain names. .gov is sponsored domain name. And here it means that, yes, you can buy such a domain name if you meet some requirements over there. And finally, we have one infrastructure domain name .arpa, which is kind of used for technical purpose. A lot of test domains, apart from that, they may contain any characters, Chinese, Indian, whatever can be registered over there. Currently, we have more than 900 domain names, top-level domains, sorry. Not that much. Second-level domains that are located in a hierarchy just below top-level domains, they also have some types that are identified. Those are country code domains. And here we have as an example, co.uk or com.fr. We also have historic second-level domains, which I believe that are not used anymore, but from some reasons that were created in the past to serve some purpose. And that's pretty much it in terms of second-level domain names. Now, what is the difference between domain name and host name, actually? And there are two definitions that I would like you to be aware of. One definition, domain encapsulates host names, which means that in that example, we have a domain name called Akamai.com and 4 host names, mail, www, NS1, and SMTP. Domain encapsulates host name, contains host names. The other definition that is also popular, common, host name is a domain name that is assigned to the computer. Assigned to the computer, in other words, means it has an IP address assigned. So there is a physical machine behind the domain name. Now, question to you. Which of those are domain names and which of those are host names? Anyone can share some thoughts here? So this one is host name. Which one? Number 3? 1 and 3 host names, okay, so we have 3 votes. 2 and 5 domain names. Now, in fact, the answer is it depends. Because at this point, we cannot judge, we cannot definitely say that, this one is a host name or not, because we don't know if there is any machine, physical machine behind that domain name. It can be a domain name with other host names in front of. So you may have like a.smtp.mydomain.com, bcd, and so on. The same goes for each other domain name here. And number 2, it can be a host name also, if there is an IP address assigned to this domain name. It means in that case, it will be domain name and a host name in the same time. So as long as you will not do any dig, you will not figure out yourself if there is any IP address assigned here, we don't know. Let's organize hierarchy then. We have our tree. Let's put Akamai domain name here. So what do we have here? We have top-level domain. We are reading from the bottom to the top. So .com is a top-level domain. We have second-level domain, Akamai.com. We have finally host name part, www.akamai.com. Now, on top of that tree, there must be something that is creating a tree, organizing the tree. There must be some root always, otherwise it's not a tree anymore, right? And the root is a root domain or just dot, or just main domain. Let's try to manage this somehow. Each independent part of DNS tree that is maintained separately is called zone. Here in that example, we see that the guy on top of that is maintaining everything that is below. That one is maintaining everything that is below, and that one is maintaining this part. Now, how many zones do we have here finally? We have root zone, dot. We have .com zone, and we have Akamai.com zone. Now, is this a zone? Is this maintained separately or not? Can be. Again, you learned. It depends. It depends because we really don't know if there is anything below that to maintain. If there are any other domain names, any other host names over there, then yes, we can maintain those host names. But if that's the like a final step, final host name, and there is really nothing more below that, there is no need to create a zone for that. It can be just a single entry, and that's it. Now, what is zone file and how it refers, how it is managed by nameservers? Remember that simple mapping. Zone is described in zone file that is maintained by nameservers. Now, our special root zone is described in root zone file, again, special zone file for the root zone, dedicated one, is maintained by root nameservers. So what are those root nameservers? What is that root zone file? Why we are spending a few slides on that. A root zone file is managed by one organization, ICANN. Interesting thing is that if you want to modify that one, if you want to introduce new domain name, it has to be approved by United States Department of Commerce. So everything is controlled over there by US. Here's the location where you can physically download the file, open in your browser and see what's inside. It has to be downloaded manually each time when you are setting up, installing new DNS server. It's not updated frequently, so it is pretty safe. It has to be uploaded manually to each single DNS server in order to work. Otherwise, DNS resolution process will not work because we don't know where is our root on the tree. Now, root name servers. They are, you can imagine, crucial part of the internet. We have 13 root name servers serving the traffic for more than 3 billion users. Is it enough? Just 13 machines for 3 billion users. Well, not really. Jumping into details, 13 name servers means they are starting from capital A to capital M. So you have 13 domain names that are maintained by 12 different independent organizations. They are using Anycast protocol. It means that behind one IP address, you may have many physical machines, and the router will choose the closest one to you. So in this moment, in this year, we have more than 500 physical machines doing the root name servers, root zone resolution for us. Interesting page for you to open, showing how many of them and where they are located. And so, for example, you see that we have like 47 somewhere here in Europe. Here, there are 7 of them in an island. Now, zooming this a little bit, there is 4 in Warsaw, and I just popped up details of one. So you have IPv4 address for that one. You have an organization that maintains that one. And here it's F letter, which means that the domain name for that is f-rootservers.net. The page is updated in a real time, so you can check how many of those where they are located. So what types do we have? What is zone file? What server types do we have? Zone file, so something that describes a zone, is a text file. It's not encoded. It's not encrypted. It's just a text file, plain text file that you can read. It describes DNS zone, pretty obvious. Syntax is defined in RFC. Now, how it looks like. It all starts from the origin. The origin is a directive. It starts from a $ character. It means that it is processed in a special way. It is not just a string, but it has some meaning for a DNS server. In this moment, the origin is Akamai.com, which means that we will be describing Akamai.com zone below. Then there is another directive, time to live, which is saying for how long we should cache all records in that zone file if it is not overwritten below. Below that section, we have different resource records. They are generally following that syntax. So you have an owner for that, so the domain for resource record, then you have time to live, which can override the default one specified above. Then you have resource record type, which is always IN right now. Then you have class, so family for the record. And finally, the value, which is an entry we are looking for. What are most commonly used resource record types? Well, we have to start from that one. It's the most important one. It's crucial for the zone file to exist. It is called start of authority. So you see that it is defined for Akamai.com zone, domain name, the class is internet, type is SOA, and then you have special syntax, which is saying that this is a name server for that one, for the domain name, for the domain Akamai.com. Here you have administrator email address, in case there are some technical issues. And then you have, in a bracket, you have few numbers. First one is the most important one. This is serial number. The meaning of that is each time when you are doing some modifications in the zone file, you have to update the serial number. Otherwise, other name servers will not apply those changes. They will not see what you updated. Then you have few values that are saying for how often secondary server should be asking for updates, how long negative records should be cached, and so on. Let's try to focus on the first one now, and I will be introducing later on other records if necessary, other entries. Apart from that, also records that are crucial for the zone file are Nameservers. You need two of them. So you see that for Akamai.com zone file, Nameserver is NS1. For Akamai.com, Nameserver is NS2. What is nice here? I skipped time to live, which means that default one will be applied, the one that was specified just at the very beginning. You see that there is no dot here, which means that this is not fully qualified domain name. If it is not fully qualified domain name, our DNS server will automatically append the origin. So each time when we are looking for that, our name server will give us ns1.akamai.com. And finally, this is just a replacement for origin directive. So you see that directive, in that case origin, has some other functionalities here, has some other meanings, can be processed somehow, is used in different places. A record. Again, hostname part, domain name, time to live, which is 20 seconds right now, class, type, and finally IP address we are looking for. Similar one for IPv6 format. There is a difference in terms of the type, and obviously the value itself must be different because it's another IP. Now, again, you may notice here that there is no dot, which means that DNS again will append our domain name here. You may also notice that we have multiple entry for actually the same. It means that we may have many entries for the same name for some record types. For a record, it is allowed. Mail exchanger. What is mail exchanger? It is actually mail server that is responsible for accepting emails from my domain. So when I want to send an email to Akamai.com, I need to know where should I send that email. And that's the place to look for. So my DNS has the knowledge. And again, we have that will be replaced by a domain name. We don't have time to live here because it's not there for that kind of record. It's not required in this example, but you may have, obviously. Additionally, we have priority. Lowest priority takes precedence, so will be used. We also don't have a trailing dot, which means that, again, origin directive will be automatically appended. CNAME, canonical name, widely used in Akamai. It's just an alias for the domain name, really. So when I want to open Akamai.com, my DNS, Akamai DNS is saying, just go to another domain.com, www.anotherdomain.com. I don't have this information. I'm not an authority for that. It's few more. I'm not going to describe them here. Some of them are used for security. Some of them are not used anymore. Let's just focus on the most important records and try to keep them a little bit separately for this presentation. Now, question. Assuming this is a complete file, what is missing here? What is wrong here? You know the answer. Any thoughts? So what will happen if there is no that? Our name server will automatically append Akamai.com, so we will end up with something like mail.akamai.com, which makes no sense. Server types. So what are different server types? What are their roles in the internet? Why we have different server types? Let's talk about that now. First of all, we can divide DNS servers into master and slave. Master is also known as a primary name server. We can say that this is primary name server for the zone or for the domain. We are also saying that the zone or domain is delegated to that master server. Master is the one who is maintained manually by domain administrator. There is no other way to update this one. Of course, you may have some UI on top of that, but still, the job has to be done by a human being. On the other side, we have slave, which is also known as secondary name server. Again, we are talking that this is secondary for the zone, which means that zone is also delegated to this name server. The difference here between master and slave is actually here below. So the zone is not updated manually anymore. It is updated automatically by the process called zone transfer. So what is a zone transfer actually? Zone transfer allows us to keep master and slave synchronized so that they have the same knowledge about the zone file. How it works. So imagine you have your master server. You are DNS administrator. You are doing some modification over there, changing some IP address or introducing some record, whatever. Now, master server is clever enough and is aware of the location for each server, for each slave server. It means it is sending, after zone is updated, it is sending a notify message, meaning something is changed. Now what slave does, slave is asking for start of authority request resource. Why? Because slave has to compare two values. Serial number that he already has with a new serial number he already received. Now, if those numbers are different, slave server will initiate zone transfer. It means he will try to download data from master to update the zone file. Obviously, he will get the data from master and update in a memory, in a disk, whatever. Now, in terms of zone transfer, we can have full zone transfer, which means just give me entire file. I don't need to know what was changed. Give me everything. And we have incremental zone transfer, which is a little bit more clever. Give me just the difference. So tell me exactly what records were removed and what records were added to the zone file. And I will apply those changes to my existing zone file. So you see that this one, the entire process, was actually triggered by that guy who did some changes. But zone transfer can be also initiated by the slave server itself. How it happens? Slave server has a configuration of the zone file, initial configuration, saying that he should be asking every 1 day, he should be asking master every 1 day if there are any changes to the zone file he already has. So, and he does that. Each day he is asking for SOA record to get serial number. He's getting the response back. In between, he's comparing serial numbers to see if there is any difference, if something was changed or not. And if something was changed, again, same process follows. Full or incremental zone transfer. He's getting some data from master, applying, and it works like that. Now, on one side, you have master-slave. That's from how zone file is maintained perspective, division. Now, on the other side, you have a division based on the role. So you may have caching name server that is called resolver. What is that, caching name server? So imagine you want to open Akamai.com domain name. You always have some DNS server you are using. This is something you are getting by default from your internet service provider. So you are reaching that name server, and this name server resolver, the one you received from ISP, is doing the job for us. So resolver is aware or know how to get that information, how to resolve IP address for Akamai.com. So it's going to master slave, digging for a record, getting the information back to you. A record has a time to live of 1 hour here. The same time to live is propagated to end user. It's also 1 hour over there. What it means? After some time, you want to open the same page again, or another user being in the same building using the same DNS server wants to open the same page again. He is initiating same request that lands on the same DNS server in your ISP. Now, in this case, because of that 1 hour, record is cached over there, so there is no need to go all the way down to master slave and get the information from there. We just can return it from the memory. Now, for how long the record is valid here? What's the time to live that is returned to end user here in the second request? Is it also 1 hour? Well, it depends. It's 1 hour minus the time elapsed between two subsequent requests. So just to recap on that, caching name server, that is called also resolver, caches whatever is necessary, taking into consideration time to live for the record. Now, forwarding name server. It is also known as proxy name server. Also is used in a special circumstances. So imagine you have huge office, a lot of users over there. They are using same DNS server, generating as a result huge traffic to the name server, or huge, well, small city even can be using one name server. Each user is asking for different domain name, just to make it more complicated. So our forwarding name server is smart enough and will delegate the resolution to different caching name servers. He will not try to do the process himself because it's too expensive. They will do this for us. He will get the response back and return it finally to our users. So you see that it saves a lot of resources on the forwarding name server. It's one way how to offload the name server that is really doing a lot of processing. What other types do we have? Let me discuss name resolution process a little bit here. You know that we have a caching name server here. We want to open Akamai page. Let's assume nothing is cached over there. Now, caching name server has to reach master or slave in order to get the information for the domain name, to get the IP address we are looking for. Now, master and slave for the domain name is called Authoritative Nameserver. It means that he is the one who has the knowledge. He is an authority for that. Let's jump into name resolution process, but let's try to describe it in details, not skipping anything here. So we are typing Akamai.com domain name. The request is landing in our caching name server, the name server from ISP. It has a root zone file over there, configured by DNS administrator, so that our caching name server knows where is a root name server. What it does in the next step, he hopes that root name server can answer what's the IP for Akamai.com, for the domain, for entire domain name, for the host name. But unfortunately, root name server is the one who is aware of .com only. So all he can say is, I don't know, but I know who may know this. So he's giving a name server for .com domain name. And then again, our caching name server is reissuing, is initiating same request, but this time to .com name server. And again, we are asking for an IP address for Akamai.com domain name. But this one, again, does not have that knowledge, but he knows who may know this. So we are asking the server, we are asking name server for Akamai.com this time. So that's name server for Akamai.com for an IP address for www. And apparently that guy has that knowledge. So he can give us the IP we are looking for. And here it comes. We have some questions to this process. I'll take it as yes or no. Domain registration. What you want to do, what you need to know if you want to register some domain name. So let's assume we have a domain name. Well, maybe not Akamai.com is not best example here because it can be busy already. But you may figure out of a wonderful name. You want to establish a company and you are looking for a domain name for that. What should you do first? Well, first of all, check who is database. Who is database is an online database that contains information about all registered domain names in the world. There is different whois databases for different type of domain names. So you may have different whois database for .com, for PL, and so on. So you need to know where to look that information, but finally you will get that. And If you will get the answer that the domain name is not registered, then you can go ahead with the process. The next step is find registrar. So registrar is a person, an organization that is responsible, that can do changes in a zone file for us. What kind of changes we will be doing? We want to register our domain name, which means we want to specify in .com zone file where are our name servers, so that anyone who is asking for Akamai.com or everything below Akamai.com can access our name servers and query them, not domain.com. Registrar can, apart from domain registration, they can also host name servers for us. So if we don't have physical machines at our premises, we can ask them, we can find the registrar who can host primary and secondary name server for us. They can also give you some extra, probably, space for your page and so on, right? So it's plenty of them. There is also different price for the domain name, so it's really hard to answer if this is expensive or not. Try to find any and compare the price. That's my suggestion. And see what they offer. Now, if you find the registrar, you need to set up authoritative name servers for your domain. What it means? Well, if someone is asking for Akamai.com, we cannot just send the request to nowhere. .com name server must be exactly aware where he should delegate the request. So there must be some authoritative name server who can generate a response at this point. Now, this is something that is very often also done by domain registrars or domain resellers. So very often we don't have to worry about that, but it happens that we want to host physical name server on our own. So what the registrar does technically, he will put two entries in .com zone file. He will put two entries saying, where are our name servers? Authoritative name servers configured for my domain. Authoritative means master or slave. Those entries, we can call them also delegation. It means that .com name server, he only may know who is a name server, who has that information, but he is not authority. Authoritative name server is only the one who is master or slave for the domain name, for Akamai.com. So the only authoritative name server is this one. I know this information. He is saying, I know who may know this. Delegation versus authority. Now you may ask if this entire process is safe. Coming back to our example, but this time let's use some bank domain name. So we want to do a money transfer, whatever, purchase something, do some whatever operation, wire some funds. Let's open our bank page and assume we are getting correct results. So what our caching name server does, he is asking for a address for www.mybank.com. And again, same process follows. So we are looking for authoritative name servers for the domain name, trying to get IP address for that. Here is the IP address for the page we want to open, but there is bad guy here. Bad guy who can poison DNS response, meaning he can replace correct record with the one that is invalid, with the one that is pointing to his machine, to the other page, whatever. This is not something we are looking for, but unfortunately we are not aware of that. So we are trying to open the IP address, the domain name, and in fact, as a result, landing on his server, not our bank server. So that is called DNS poisoning. Now, how to protect this? Can we be sure? Can we make it more safe somehow? Well, the answer is yes. DNS, by default, doesn't support it, but you can configure something called Dns Security Extension, which does two things. It can authenticate our response. So for us, it is important because we exactly know, or our computer knows, who sent that information. Our computer can judge whether the information was sent by the name server, by authoritative nameserver, or bad guy. Second thing DNSSEC does, DNSSEC is checking message integrity. Message integrity, in other words, he's checking if the message, if the response was changed in a meantime or not. So he can judge, he can compare in the algorithm which value is correct. And if from some reason the value seems incorrect, he can just discard it and not use it anymore. Now, I have two more slides that are capturing, let's jump into more technical details. Those slides are capturing Wireshark request and response captured from sample transaction. Just for you to be aware how it looks like from a protocol perspective. So what we have here, maybe it's not clear perfectly for you, but that's a request. There's a DNS query, a request for Akamai.com domain name. What is interesting, the port that is used is 53 here, that's standard DNS port. And finally, we have the response. In answer section, you see that Akamai.com is CNAMEd to some HKey.net hostname. We will be looking into the details into our labs. It's just for your information right now as a reference for next steps. Any questions?